This slideshow is to introduce you to system principles. So let's talk about understanding systems. The laws of nature determine how objects behave in our physical environment. For example, the law of gravity. Gravity is not Newton's law, nor did he invent it. He only observed, understood, and described it with a mathematical constant. Gravity has been around since the beginning of time. You can ignore gravity, gravity will not ignore you. You can also not break the law. You can only break yourself against the law, and it's because the law is unbreakable that you get hurt when you ignore this law. Similarly, the laws of systems are just there. They're laws of nature. You can ignore them, they will not ignore you. So the important thing is to understand what are systems, and once you deal with a system, you have to apply the laws whenever you make a decision to consider these laws. Otherwise, these laws will come back and hurt you. Both organizations, be it profit, not for profit, are systems. Also, projects are systems, which means we have to apply the laws of systems when we make decisions about them. So let's talk about the laws of systems, or the system characteristics. The first system law is that all systems are goal-seeking. They exist for a purpose, and they're subject to necessary conditions. Similarly to a racing car driver and his car, which is a complete system, they've got a clear goal, and they also know what the necessary conditions are. We've already talked about the goal and necessary conditions of organizations, for profit and not for profit. The important thing is for profits. That's what we're concerned with. The goal is to make more money now as well as in the future. The necessary conditions are, first of all, satisfy your market consisting of the different role players. And then the second necessary condition, look after your people, your suppliers, and your investment. Similarly, projects have goals dependent on what the nature of the project is, but a project also subject to necessary conditions, limited by time, limited by money, limited by resources. The second system law, or system characteristic, is that measurements are derived from the goal and the necessary conditions. It has to happen in that particular sequence. You cannot do it the other way around. It just will not work. The third system characteristic, or system law, is that when you look at the system, all components within the system must support the goal and or the necessary conditions. It's about two things. First of all, it's about necessity. Secondly, it's about sufficiency. So each component on its own is necessary for the system to achieve its goal. Without it, the system will not achieve its goal. And the sufficiency means that all the components together are sufficient to achieve the goal. Considering it from a project perspective, each of the tasks we are doing in the project are necessary, and all the tasks together makes it sufficient to achieve the project goal. Also make sure that we only have included in the system what is necessary, and anything which is not necessary, for sufficiency, should be excluded. Our next system principle is actually one of the problems we've already addressed and talked about. Measurements influence behavior. The important thing in a system is to make sure that you have the correct measurements so that you can achieve the correct behavior and therefore arrive at the proper outcome that you would like to achieve. This is an interesting system principle. It's also the system principle which is known as a system is more than the sum of its parts. If I look at that racing car with its driver, the system, total system, and I disassemble it into its component parts, that system will absolutely go nowhere. The important thing in a system is the relationship between the parts. Therefore, in order to be able to move forward, which is the emergent property, I have to assemble all the components in the correct combination. So the important thing in a system is not the component, but the relationships between the parts. That is what gives us the emergent property. In this case, it's forward motion related to the goal, winning the race, related to the measurement speed. None of the components on their own has this characteristic, except maybe for the driver on his own. He can move forward, but he's not fast enough to win the race. If he was, he would have been the system. But because he's not, doesn't have sufficient forward motion, therefore it just becomes a component. In addition, the driver's ability to move forward has got nothing to do with the car's ability to move forward. So his legs moving him forward does not move the car forward. In projects, the emergent property is achieving the goal. In organizations, for-profit organizations, the emergent property is profit. For a human system, the emergent property is life. No component on its own is alive by itself, but the components assembled together in the right combination with the right relationships that allows us to have life. The next system principle deals with synergy, which says that small changes can produce big results. So 1 plus 1 is 4, or 8, or 100. Now I've already indicated that we must be able to do a little bit of math, and now it seems as if I cannot do it. Well, in systems, the mathematics is not linear. We are very used to linear mathematics, especially cost cutting. Similar to looking at the racing car, if you want to reduce weight, a weight reduction on any component means a weight reduction for the car. However, an improvement in a component does not necessarily constitute an improvement in speed. So the important thing in systems is to find that leverage point where you can make a small change, and it does not have to happen on all the components. It's typically one component only, where you will have a big outcome, big result from that change. This will be demonstrated in mini case number 2. Systems also exhibit counterintuitive behavior. Counterintuitiveness is one of those characteristics that help us to tell us that you understand or don't understand your system. Counterintuitiveness means you make a decision with a certain expected outcome. For example, I might add more resources on the project, expecting that the project will finish earlier. What happens in reality then is that the project is delayed, which means the opposite happened to what we expected. So it's what is known as a counterintuitive outcome. So how can this be explained? Maybe with the addition of more resources, they start getting in one another's way, and therefore the task is delayed and thus the project delayed. Counterintuitiveness tells us that there's some relationship in the system that we do not understand, or we are making a wrong assumption. So the moment this is experienced, it tells us that there's something wrong in our understanding of the system. All systems are constrained in their output. No system can achieve an infinite amount of output. We use the analogy of a chain. A chain is only as strong as the weakest link. So if you want to improve a chain, you must find the weakest link first. And only if you improve the weakest link will you improve the chain. Similarly, organizations are constrained. No company makes infinite outputs, infinite profits. So therefore you are either constrained internally by capacity, or you are constrained by the capacity of the market to buy, in other words, demand. Projects are also constrained. We'll have that discussion in class, exactly where a project constraint is, because if there were no constraints, then you will achieve the output of the project immediately in time. So the project duration will then be 0. However, we know in reality it's not possible, so therefore projects do have a constraint. And should you want to improve your project execution, obviously you will have to focus on the constraint. Continuing with the analogy of a chain, if I improve a non-weakest link, I will not improve the chain. Similarly, if I make a non-critical path task faster, then the project will not finish faster. So the important thing is to know where to optimize or to improve. We know that optimization is not possible, so it's really about improvement. So make sure that you improve where it's going to make a difference. Whenever you make a decision, you must be able to explain how the decision will lead to the desired outcome. And often the cause and effect are distant in space and time. So you might make a decision now, but you will not see the effect until much later. For the human system, smoking might be a good example. You might be smoking today, having no effect on you. In future, you're going to start suffering from the negative effects of what has happened a long time ago. It's important in systems, and whenever we make the decision, we must be able to explain how the decision will lead to a certain outcome, a certain effect, even though it might be in a different place and a long time from now. Second last one, your system is subject to entropy. This means that it's just complying with the law of physics, the second law of thermodynamics, which says that nature has the tendency to deteriorate and spontaneously break down relationships. That's why we need maintenance. That's why Murphy takes place. That's the uncertainty, which is part of our reality. And we've got to take cognizance of the fact that we have to do maintenance. The last one, your system is not operating in isolation. There are impacts from external environments which might influence your organization. It might influence your project. We've talked about some of the external impacts, such as the economic climate, exchange rate, weather. But we do know what those things are. So even though we cannot control them, we can plan for them. And within our systems, we must make sure that we also plan for those eventualities. However, when a project does not perform well, or whether the project becomes a failure, often we tend to claim that it was the external influences, when in reality it might have been bad decision making within the projects. So we must be able to distinguish between bad luck, where the external environment is really the cause for the failure, or whether it is bad management or bad decision making within projects. So what we're going to be doing is we're going to be applying all these system principles on mini case number 2, and that part we will be doing during the morning of the contact session.